Hello everyone, welcome to the lecture series on operating system. I am Mrs. Gitanjali Mahamunkar, lecturer and research scholar at Department of Computer Engineering, Dr. Babasaheb Ambedkar Technological University, Loneri. The books that I have referred for this lecture series are Operating System Concepts by Galvin and Operating System by Achyut Godbole and Atul Kahati. This is my 10th lecture in this lecture series and it is on process. The topics that I am going to discuss in this lecture is process, what is a process, the different states, process states, the state diagram of course, and the difference between the process and the program. So if you want to watch my previous lectures, please do visit my channel Learn with GSM, and if you haven't subscribed yet, please subscribe to my channel. So let me start with what is a process. Let us understand what is a process. Process of course is the program in execution. So whatever code you write, when you execute it, when it is undergoing an execution, it is a process. It is basically an asynchronous activity, or you can say an active entity that requires a set of resources including a processor, a program counter, registers to perform its function. So multiple processes may be associated with just one program, right? So when process execution must progress, it progresses in a sequential order. It is also called a task. You can say task is a single instance of an executable program, right? So process, you can say, could be related to, there could be many processes, as I said, related to a program. So a process has to be in memory, as discussed earlier in the previous lectures. You must visit my channel for them to watch them, and you'll understand that process has to be in the memory to execute, right? So there is a difference between a program and a process. Program is basically a passive entity and process is an active entity. So program resides, it contains all the instructions, and when they are into a sequence of execution, we say it is a process. So program can reside onto the disk and continue to exist until you delete it, but process exists only for a limited time span. That is when it is executing, or when you create a process, rather when you want the program to execute, you create a process using a system called fork system call. It gets created, and then when it completes its execution, it ends. We say the process has ended or terminated. So it exists for a limited time span onto memory. And then program, so you can say, is a static entity, whereas process is a dynamic entity. I suppose this is quite clear now. So let us see what is memory layout for a process, like how it resides on memory. Each process has its own address space. So address space is divided into basically different regions. You have the text region, okay, see this is the text region, then you have the data region, okay, and the stack region. Now text region, it stores the code that the processor executes basically, and data region, it stores variables and dynamically allocated memory that the process uses during the execution. It can contain the uninitialized or initialized data basically, so in the program. So that has that comes under the data region, okay. Now talking about the stack region, it stores instructions and local variable for active procedure calls. Whatever calls, procedures are called and are running basically at a particular moment, then whatever instructions are associated with those procedure calls, or the data that is associated with these procedure calls, the variables, local variables, are they come under this stack region, are stored onto stack. Now as I said, process is a dynamic entity that executes a program on a particular set of data using the resources that are allocated by the operating system. So it can run to completion only when all the requested hardware and software resources have been allocated to the process. So process can complete its execution only if it has got all the resources which are of course allocated to it by the operating system, and the data that it requires to complete its execution. So you can say it should have all the hardware and software resources with it to complete its execution. Whereas program, as I said, is a passive entity. So a program becomes a process when an executable file is loaded into a memory. Okay, and a process may be independent of other processes in the system. So after booting operating system, it creates foreground processes and background processes. Right now, foreground processes are the one which interacts with the user, and the background processes are used by the system. So a process is used as a fundamental unit for resource allocation in operating system. Okay, and it normally has its own private memory area in which it runs. So text region contains the executable instructions, and it is to be placed below the heap or the stack. And initialized data region contains static and global variables that are initialized by the user. Okay, and the uninitialized data region, that is this part, it contains all the static and global variables that are initialized by the kernel to 0 basically. And heap is the region which is used for dynamic memory allocation, and stack, as I said, contains the program counter. Now what is program counter? That I'll explain you in the lecture when I'll be where I'll be talking about process control block and all. Okay, so now this was all about the memory layout for a process. Let us move on to what are the process states basically, and what is a process state diagram. Now each process has an execution state which indicates what the process is currently doing. Now process descriptor is the basic data structure used to represent the specific state for each process. Now what happens when you actually create a process, and then when it completes its execution and reaches the termination state, in between the process transitions from one state to another. And what all are these states? They are new, ready, running, waiting, and terminated. Now new is the state when initially when a process is created, it is in the new state. OS creates new process by using the fork system call, right? So this is the new state. Then when a process is created, it might be onto the onto the disk. Okay, in the jobs scheduled for like you have a job scheduler which will select one out of these process and put it into the ready queue in the memory, right? So when it is admitted into the ready queue, it goes to the ready state. Now these are ready state means it is into the state where it is competing for the CPU. Okay, and it reaches to the head of the list instead of the queue. Then it will be the scheduler dispatcher would dispatch it to the running state. That when it is selected for execution or when it is allocated the CPU, it will move on or transition from the ready state to the running state. Now while it is running, while it is executing, there might come a situation when it gets interrupted. We have talked about software and hardware interrupts in the previous lectures. You can watch it on in the playlist, okay, on my channel related to operating system. And then you can then what happens is when it is into the running state and it gets interrupted, it will move on to the ready state again. Okay, waiting for the interrupt service routine to resolve the interrupt, and then when it is done, again when its turn comes, the scheduler dispatcher will again dispatch it to the running state. It will execute. Now this time if it executes properly, it will exit and reach the terminated state. Otherwise what will happen is, so terminated state is the one where the process completes its operations and releases all its resources. Otherwise what happens when it is into the running state, that is the process is currently being executed, then the OS allocates all the hardware and software resources to the process for execution, or while running, if suppose it is supposed to do some input output activity, or there is some event that is occurring, like maybe some sort of interaction is going on between the process and the user and it needs the response from the user. Maybe it is an interactive process, or maybe it is a cooperating process, or needs some communication from some other process or something, then it will have to wait for that event to occur. And when this is happening, it moves itself to the waiting state from the running state. So process is waiting until some event occurs, such as completion of an input output operation, and then when it completes, it again goes back to the ready state. It is again added to the ready queue, from where again the scheduler may dispatch it when its turn comes, and then after executing successfully, it might go to the terminated state. So these are the various states through which the process moves or transitions, and this diagram that you see over here is the process state diagram. Okay, a state diagram is composed of set of states and transitions between the states. So what we have seen in this lecture is what is a process, what is the memory layout for the process, difference between the process and a program, and the process state diagram. So I hope you'll be able to answer all these questions, because I am sure you have understood all the topics discussed in this lecture, that explain what is a process, explain the memory layout of a process with neat diagram, state the different process states with neat process state diagram, and the difference between a program and a process. So if you have watched this video and you have liked it, please do not forget to press like, comment your views about it, and share it with your friends. If you haven't subscribed to my channel yet, please do not forget to subscribe to my channel. Thank you.